Welcome to week 8, day 35 of the fall 2024 Programming Fundamentals with C Sharp. I'm Jim Coppin with Rankin Technical College. Today we're going to be covering wanted to kind of do a little bit of review from last week, just a quick little review. There's a lot of concepts in there that's important, especially when you go for interviews and things like that. A lot of concepts are important, and just for programming in general. So I'm going to go ahead and do a quick review. I did want to look at wanted to look at IComparable demonstration just to kind of discuss that. I know that was one of the labs implemented that interface, and just kind of want to go through that real quick. Also want to just do a quick review of polymorphism. And then after that, I'm going to go ahead and go through chapter 7, how to handle exceptions and validate data. So let's see here. So as far as inheritance is a fundamental object-oriented programming concept where a new class derives a derived class is created based on an existing class, which is the base class. The derived class inherits the members, fields, properties, and methods of the base class, but can also extend or modify them. And I know this is a review, just kind of want to do a quick one on this. And kind of, to move a little higher up from this, as far as from an object-oriented programming perspective, there's 4 concepts that are important for to be able to say that a programming language is an object-oriented. They're not all object-oriented programming languages, okay? But C# is one of them. And to be considered an object-oriented programming language, there's 4 things that have to be there, okay? There has to be inheritance. That's one of them. There has to be concept of abstraction, and I'm not going to go into that right now, but we'll down the road here, there's probably going to be a few different times I'm going to go through some of these concepts again. I think it's really important for you to know, and especially when it comes to interview questions, understanding these concepts is very important. And actually, abstraction isn't even covered in the book. They don't even talk about abstraction, but inheritance is a big one. The other one's encapsulation, which we kind of seen before. That's where we had those like private instance variables, and so to access those private instance variables, you couldn't directly from outside that class. If you had those private, you can't access those private instance variables directly. You had to go through like the properties or some getters or setter methods, right? Or those properties, right? So that's called data hiding, and that's encapsulating that data. So that's another concept, and the other one is polymorphism. Okay, and I'm going to go show you an example of polymorphism here in a little bit. So just kind of it's a kind of a difficult concept to understand. Don't worry if you don't understand it right away. As time goes on, you'll have a better grasp on that. But as far as inheritance here, the key concept is you got the base and the derived classes. And we've already the labs from this chapter from week 7, we've already done this, right? Just as a quick review though, it talks about protected members. So just to review, protected members of the base class are accessible in derived classes, but not outside them. So if you ever and I know that from our UML, if it was a hash or a pound, right? A hash or a pound sign, that means it's a protected, and that protected field, that protected member is only accessible within that class or the derived classes. We learned about overriding methods, right? So you have your override. You have your override in the derived class, and for that to be overridden, it has to be marked as virtual in the base class, right? Um, or abstract as well. And just a quick review. We're talking about abstract here in a minute. So, um, okay, let's see here. Polymorphism. A base class reference can point to an object of a derived class, allowing for what's called dynamic method binding at runtime. And don't worry if that's kind of confusing. We'll go through a little more, and we'll go through this, like I said, a few different times in this course, just so you kind of understand a little better. This enables methods to be called based on their actual object type, not their reference type. Okay, and we're going to go through an example here in a little bit. Now, abstract classes cannot be instantiated directly. So if you define an abstract class, the whole purpose in defining an abstract class is you want it to be inherited by, you want it to be derived, right? Inherited by other classes, right? That's the whole purpose of an abstract class. So basically, you're usually defining a bunch of methods or properties, and you're wanting all of the derived classes to provide implementations of those, right? Or to use all of those in their derived class, right? So they cannot contain abstract methods. They can contain abstract methods which must be overwritten in a derived class. And they can also include non-abstract method members as well. So if they're non-abstract, you don't have to override them. If they're abstract, you have to override them in your derived classes. Okay. Sealed class cannot be inherited. So when you put this word sealed, this avoids things from being inherited. Now there's some certain classes that are very important, like maybe some functions to do with math and that, where you don't want to have certain classes being inherited and overriding certain things in those classes. So you can mark that you want to kind of lock that down. So you use that sealed keyword to lock that down. Okay. Let's see. The base keyword is used to call base constructors or access base class members. Okay. Now a quick review of interfaces. An interface is, you look at an interface as it kind of defines a contract between the interface and any class that wants to implement that interface or other interfaces, right? So remember that in general, classes, from a classes standpoint, not interface, from a classes standpoint, classes inherit other classes, right? But as far as interfaces, classes don't inherit interfaces, they implement interfaces, right? Now, from an interfaces perspective, interfaces can inherit from other interfaces. I know that can be a little bit confusing. You can get used to that as time goes on. But interfaces can inherit from other interfaces, right? But a class cannot really inherit an interface. It's really called implementing an interface, right? And so when a class implements an interface, it's a contract between, you look at it as a contract, right? It's just, kind of a concept thing. It's a contract. It's like an agreement. Okay, if you implement my interface, if you create an interface, whoever implements my interface, well, you're going to have to overwrite these methods, right? And we're going to take a look at an example of IComparable where that happens. If you implement IComparable, you have to overwrite the compare_to method, right? Implementing interfaces. Okay. And the other concept I also wanted to point out is the idea that from a class to class perspective, a class can only inherit from one other class, can't inherit from multiple classes, but a class can implement multiple interfaces, right? Can implement multiple interfaces. All right. So I don't want to go through too much here. We kind of, you've learned all this. Basically, to do those labs, you'd have to have a pretty good concept on most of this anyhow, right? I do want to look at a couple examples here. So as far as the IComparable, and I know that this was part of one lab, and I'm not sure if everybody implemented. I haven't looked at all the lab assignments yet, as far as from a grading perspective yet. So I will be doing that next couple days. So obviously, if you let me just comment this out. If I save that, as you can see, this is going to complain, that you have to overwrite this compare to method, right? It's complaining. So let's put that back. Oh. Did the wrong thing there. Okay, there we go. All right. So to show how this really works, so this is this is the person class. Just has a couple members here, and has this compare to, right? Name and age. Has this compare to, and it's comparing based on age, right? So this compare to method, what you're basically saying here, yeah, I don't like. Okay, so basically what this is saying here, as far as return values. So there's different things that can return. It's basically saying here, return 1 if all non-null objects are considered greater than null, right? So if it's null, return 1, okay? And so that actually pushes it down so that the nulls are not important. If you have null objects, it's going to kind of push that down as far as when you're sorting, right? So there's different things that can be returned, like when you do this compare to right here, right? And so obviously when you do this compare to, this is, if you go to definition, right? This is going to go to your compare to interface, right? This is your interface. So this can return different things. If it returns a -1, it means the current person, okay, which is this, okay, is younger than the older person. So here, let's look at the main method here first. So we basically have 3 person objects, and they have age of 30, 25, and 35, right? So the youngest one is Bob, then Alice, and then Charlie, okay? So that's the age. So here, when you're comparing, this is this specific. We're going to run through the debugger real quick here too. You're comparing the current one to the other ones, right? And I'll show you how that kind of works here in a minute. But if the current person is younger than the other person, if this current one here is younger than this other age, okay, it will return a -1. If both people had the same age, it's going to return a 0. Okay? If the current person, which is this .age, if this current one is older than the other person, older than this one, okay, it's going to return a 1. And that's how this basically works. There's really only 3 options on return values. It's going to either be 0 if they're the same age. It's going to be -1 if the current person is younger than the other person, in this case, right? Or it's going to return 1 if the current person is older than the other person, okay? I'm just letting you understand how that kind of works here internally, okay? So if we go to, let's go back here. So this is where this IComparable is actually used within the sort, right? So let's just run this real quick. Which one is this? This is IComparable. So when I run this, the first one, Bob is age 25, Alice is 30, and Charlie is 35, right? So it's in ascending order by age, right? 25 is the youngest, then 30, then 35. Now, if I just went ahead and got rid of this sort, right? Then obviously it's going to work differently, right? So it's just going to do it whatever order it was created, right? Age 30, then 25, then 35, right? So even if, let's just do this, just, you know, so you can see this. So let's keep the sort, let's see, let's get rid of this. And then let's comment this out. Okay, so we still got a sort. We're not using the IComparable interface anymore, right? And we're not using this compare to anymore. So now if we go ahead and run this, oh, well, it's going to complain. Failed to compare two elements in the array. Okay. Yep. So you're going to have this argument exception. At least one object must implement. Yep. At least one object must implement IComparable for you to do that sort. Okay. So we're going to go back there. Okay. I don't know why it's complaining so much right there now. There we go. All right. So I kind of wanted to walk through this a little bit also here. So let's go ahead and fire this up. And then for here, let's grab other, add a watch on other. And this is what, you know, you can do this yourself, you know, and really using the debugger, and we're going to actually cover this in another chapter a little more. So, you know, it always helps to be able to walk through your, you know, especially if you have a problem trying to figure out why ain't this sorting right, you can always walk through this, right? So each case here, I know you probably can't see this because it's so small, but, you know, other is Bob, age 25, and this is Alice, age 30, right? So, you know, you can actually use the debugger to see what it's doing in each case, okay? So you can actually see what's being returned in each case. Just wanted to point that out a little bit. So it's going to, you know, like I said, it's going to be comparing both of these, and it's, you know, you're going to have three different options here, right? It's either going to return 0, -1, or 1, right? So I guess we don't really need to talk about that too much more. What else we have here? Yeah, as far as polymorphism is concerned, yeah, I have a different one I want to show you on that. So here's a polymorphism example. And so basically you've got a animal class that has just a method called make sound. And then you've got two different derived classes, one dog, one cat, both inheriting from animal, and they're overriding the make sound, right? They're overriding the make sound. And here in your main method, you're creating new objects. but your reference type is animal. So the first one is animal, reference type animal, right? But you're creating a new animal. But here you actually got an animal reference for my dog and my cat, but you're actually creating a new dog and new cat, right? Um, so remember that, like for polymorphism, the base class reference can point to an object of a derived class, right? So this animal, this reference can point to an object of a derived class, which is the dog or the cat, right? Um, and the fact of it doing that allows for dynamic method binding at runtime. So, we talk about compile time and runtime, and when we're using these WinForms act the console apps or that, it's kind of compiling that for us, right? It's taking care of all that. But after it compiles code, but then it runs the code, right? After it compiles it, it runs it. All of these things aren't determined at compile time. Like we know when we're creating code in our editor, when we have a compile time error, the editor's usually going to tell us, oh, it's going to be underlined in red. You're going to see something's wrong. That's a compile time error, right? The editor's just helping us, determining that is going to be a compile time error, right? But runtime actually happens after it's compiled, right? So, and sometimes you can have runtime errors, right? You can have runtime errors as well, right? So that doesn't happen at compile time, doesn't happen until you run it, right? So, in C Sharp, polymorphism allows methods in a base class to be overwritten in derived classes, which we're seeing here, right? The base class reference can hold an instance of a derived class. That's what we're seeing here. And when you call the method on that reference, that derived class's version of the method is executed. Okay? So my animal, my dog, and my cat are all references of type animal. Okay? The make sound method is overwritten in dog and cat. So even though the reference is of type animal, the actual type of the object determines which method is called at runtime. And this is an example of runtime polymorphism, right? Also called method overriding. Okay. Now, I know you don't get hung up on it if you don't understand all of that. As time goes on, you'll understand a lot more of that. But being able to explain what polymorphism is important, especially when you start doing interviews and stuff like that. So that's all four of those concepts, which we'll review more in the future as well. And those four concepts is abstraction, right? Encapsulation, which we talked about the data hiding and those private instance variables. Polymorphism, right? And then also inheritance, right? So we're really covering two of them, three of them we've kind of seen here recently. The encapsulation, the inheritance, and now here polymorphism, right? Let's see what else I want to talk about here. Okay. So I guess that's it for chapters 14 and 15. I think, there is going to be a hands-on test that I'll assign tomorrow morning. And I'm going to go through just a quick another interface example, because we really, in the labs, you didn't really do a lot of interface examples. So kind of walk through another interface example tomorrow for that, because I know that one's hands-on test. And actually that hands-on test is just one exercise. It's not too bad. So if you were able to do most of those labs, then you should not have any problem with the hands-on test. All right, let's get into the chapter 7 stuff here. So as far as exceptions, a well-coded application will catch specific exceptions that might be thrown and handle them. This is known as exception handling, right? So exception handling can be as simple as notifying a user that they must enter valid data. However, for more serious exceptions, exception handling may involve notifying users that the application is being shut down, saving as much data as possible, cleaning up the resources, and exiting the application as smoothly as possible. So there's different reasons for throwing exceptions. Sometimes you might just exceptions if they, we've done things where we've in our WinForms app, if they enter the wrong data or something, that we return back to them. Your data's wrong data was entered. Please enter the right data. Well, that was one way to do it, but another way to do that is actually throw an exception, and you can control that exception, and you'll still be returning it back to the user to do it, but the way that you're doing it is using an exception. Okay. So when you're testing the application, it's common to encounter exceptions that haven't been handled. So we've a lot of times, I know that you've already experienced it in your coding here in this course. Is there's times that you somehow entered the wrong data, and then all of a sudden something blew up in your thing, and you probably had to stop. You probably had to stop the execution of the app and restart it again, right? But so there's ways to prevent that from happening, and that's using those exceptions. Okay. So all exceptions are subclasses of the exception class. So there's a whole bunch of specific exceptions that .NET already provides, like arithmetic exception, array index out of bounds type exceptions. But then you can also create your own as well. Okay. So the arithmetic exception class is also a subclass of exception. It represents an exception that occurs during arithmetic, casting, or conversion operation. This class contains other subclasses, including the overflow exception, divide by zero exception. Okay. Yeah, you try to divide by zero, you'll get an exception for that. Okay, we'll look at an example of that here in a little bit. So this is how we've kind of done things so far. Is we've done converts and stuff, things like that, and we converted usually our text boxes to a certain type. In this case, it's converting to a decimal. But if that cannot be converted, it's gonna throw an exception. But in this case, we didn't, we haven't handled exceptions. We haven't done that. So, there's a way to, instead of getting this error, because usually when you get this error, then you got to stop your program, restart everything. We can actually handle that exception and handle things a little more gracefully. All right. So here's the hierarchy for. It's got 5 common exceptions: a format exception, arithmetic exception, overflow exception, and divide by zero exceptions. There's many different. It's just showing 5 common ones. Okay, and it all inherits from exception. Okay, so we'll also learn how to create our own exceptions, and we'll also inherit it from exception. Okay, we're going to inherit an exception. You can create your own exception, right? Your own custom exceptions. So here's some methods that might throw an exception. Obviously 2 decimal. We were just looking at it. 2 decimal, 2 inch. Whenever you're parsing things. So overflow exceptions is like the numbers greater than, because there are limits, even though you're not, it's going to be hard to get to some limits on a lot of these different kinds of numbers, right? On a lot of these different data types. Like an integer is a pretty big number, right? But it's possible that your number is too big. You're doing some sophisticated processing of some big numbers. And if for some reason that number is greater than that data type will hold, you're going to get an overflow exception. Okay. So that can happen on, especially like these data types, the decimals, the ints, right? Um, and this is showing you, yep, here, that's 2 decimal, and also on parsing. When you parse a string to a decimal, right? Um, that number here that you're parsing may be greater than decimal can hold, right? On here, a date time really doesn't have an overflow. It's really basically is that because dates are pretty much set. This is a date, even if the date, doesn't exist, it's not going to be that. It's basically when you parse a string into a date, it's either going to be valid or not valid, right? So you're only going to have a format exception here. You won't have an overflow exception with respect to a date time. Okay. And this is just showing you that. And I know some people have already done this a little bit. Showing a message box, and it's just showing a window forms message box that basically you can do you could test against an exception. If the exception's thrown, then you can have a message box that please enter the valid number, right, in this case. To prevent your application from crashing due to runtime errors, which I know we've all experienced that, you can write code that handles exceptions when they occur. This is known as structured exception handling. Okay, it plays an important role in most applications. So to do that, you use what's called try-catch statements, and you do that to handle, to catch and handle exceptions. First, you code a try block around the statement or statements that may throw an exception. Then immediately after the try block, you code what's called a catch block that contains the statement that will be executed if the exception is thrown by a statement in the try block. Right? This is known as the exception handler. Right? The try catch statement in this figure shows how you might catch any exception thrown by 4 of the statements in the invoice total application example. Okay, so let's just move on to that. So basically, yeah, this is kind of showing a generic type thing here. So you try all of these. If any of these fail, then it's going to go ahead. If any of these throw an exception, then it's going to do this message box.show and return that to the user, right? You can use a try-catch statement to code an exception handler that catches and handles any exceptions that are thrown. You can code a try block around any statements that may throw an exception. Then you can code a catch block that contains the statements to be executed when an exception is thrown in the try block. Okay, here's how to use properties and methods of an exception. So let's just go ahead and I think we'll go to this next thing. So the syntax of a try-catch statement that accesses an exception. You've got your try, which you wrap around all your statements, and then you have your catch. And here you're catching you state your exception class that you're catching, right? And then you have some other statements that, in a lot of cases we're talking about a message box, or you may be doing other things as well. With a WinForms app, with these WinForms apps, these GUI apps, those statements are going to be more pertinent to returning a message back to the users from a WinForm type perspective, right? There's 2 common properties for all exceptions. There's a message. It gets a message that briefly describes the current exception. And there's also a stack trace. gets a string that lists the methods that were called before the exception occurred. And if you kind of recall, we actually talked about stacks back when we talked about different collections and stuff. Remember, so the stack trace is always going to be, it's always going to be, you know, the last thing you're going to see is going to be top of the stack. A stack is always, you know, stack goes back in time. So the first thing you're going to see is the last thing that happened, right? And the bottom of that stack, you look at the top of the stack, then the bottom of the stack. The top of the stack is the last thing that happened, right? The bottom of the stack is the first thing that happened, right? A try catch statement that accesses the exception. So here you're doing a try catch on this convert to decimal. So obviously, if you pass in for your text here, if you pass in letters, this is going to fail, right? And it's going to throw in this exception. And so, you can, we're going to discuss this more. So you can actually use the generic exception, right? Or you can actually be catching specific type exceptions. There may be cases when you are fine with just using the generic exception class. So anything that throws any kind of valid exception, then it will go ahead and message this. But sometimes you're going to want to, you're wanting to catch certain type of exceptions, right? You want to know if this is a format exception, or, the problem is, when you just use the generic ones, something can throw multiple different kinds of exceptions. Well, you might want to know something a little more specific than that, right? Okay, so if you want to use the properties or methods of an exception in the catch block, you must supply the name for the exception. Okay, and what we're saying is here we got an EX, right? So here you're doing it. This is the name you're giving your exception, right? This is a developer created name, whatever you want to call it. Here it's calling it EX, right? And then in here you're calling the stack trace on there. So this will show the stack trace. This is the whole stack trace. And like I said, on the stack trace, the last thing that happened is going to be, you're going to see at the top. And it's going to go all the way down, right? And so in this case, you're using, okay, well, the other one is get type. So it's going to get the type to string. And here's the get type to string right here. The first one, input string was not in the correct format. Okay. So that your format exception. So that's the get type. This is, and in this case, this exception, this is not user created as far as the exception. These are just exceptions that belong within the .NET framework, right? These are supplied by .NET, right? So this get type, right? This get type is all been supplied based on .NET knowing that, hey, this was a input type was used not in the correct format, okay? So like we just looked at, if you want to use the properties of methods in the catch block, you must supply a name for the exception. And in this case, we supplied EX, right? The stack trace is a list of methods that were called before the exception occurred. This list appears in reverse order from the last method called to the first method called. If you're coding the try catch statements within an event handler, you can't use E for the name of the exception because it's used as the name of the parameter for the handler. Okay. So in some cases, the statements in a try block of a try catch statement can throw more than one exception. Then you may want to handle each exception differently, like what we were just speaking about. To do that, you can code catch blocks like the ones shown, that we'll look at here in a minute. Here, the first catch block catches the format exception, and the second one catches a overflow exception. And then the third one is going to catch anything that the first two didn't, okay? When you catch specific exceptions, you should realize that you must code the catch block for the most specific exception in the class hierarchy first, and you must code the catch block for the least specific exception last. So in this case, the format exception and the overflow exception type are both more specific than the exception type. All right. So we're going to take a look at that. Let's just go ahead and take a look at that right now. So here's, just giving a specific group of statements here, and then you're going to catch the most specific one first, then the next one, and then the least one. Okay, and in this case, I think that, I'm not sure. I'm almost sure here that this is just another specific. I don't think that is a format exception is more specific than overflow exception. The important one is to really remember that the most general one is basically this exception here, right? This is the most general one. So these are the format exception and overflow exception are considered more specific. So basically you're going to do a try on this. If any of these statements in here throw a format exception, then it's going to print out this message box.show. It's going to print this one, right? If any of these throw a overflow exception, it's going to print out the statement in the overflow exception one. And then for any other exception that wasn't covered in here, it's going to go ahead and print out this message box here, right? And then it's also showing you a finally block. So you've got your try, catch, and finally. Finally is optional. You don't have to have a finally. And usually a finally is for cleaning up things and common type things that you may want to clean up is, so your application may throw an exception that you just can't continue, right? And well, so you might be doing something where you've got things open. When you do things such as connect to a database, that connection stays open, right? That connection can stay open until you close that connection. And if you've got some kind of an error in your code, this is the perfect place to clean up, to take that connection, close that connection, all right? And then that's kind of a good use of that finally block. Also, another good use is when you're writing, you can do input-output type stuff that you're writing to a file system. And we'll look at that more in later on in this course, where we actually do some file input and output, where we're going to write some files to your computer, right? And so that's another thing, is where you have a stream that you write that data to your computer. And so if you have an exception, that's another place that, the finally block is the place that you really want to clean that up, and you want to close that stream before, you exit that code, right? So that's really the case of the finally block. And like I said, finally is optional, okay? And it's usually for cleaning up. So if there's something where you're not really having anything to clean up, right? We might look at some examples where we still have a finally block anyhow, just for an example purposes. But, in the real world, the finally block is really just to perform cleanup type stuff, okay? You can code one catch block for each type of exception that may occur in the try block. If you code more than one catch block, you must code the catch blocks for the most specific types of exceptions first. Since all exceptions are subclasses of the exception class, a catch block for the exception class will catch all types of exceptions. Okay. Like I said, you can actually just have one exception to catch everything, but that really isn't best practices in code. You're wanting to catch some specific exceptions, so you have more idea of what really happened there. Okay. You can code a finally block after all catch blocks, which it's optional. The code in this block is executed whether or not the exception occurs. It is often used to free up any system resources. Yeah, and yeah, I didn't mention that. So even if an exception isn't thrown, you do this try block, and everything works fine, and you finish this try block. Okay, it's not going to call these catch exception. It's not going to call these, right? If no error occurs, it's not going to enter into these statements, right? But it will still call finally. So try, whenever you got a try and you've got a finally, it's always going to execute that finally block. Okay, something to keep in mind there. And so there's circumstances where you're doing some validation on your code. You're checking your code for certain circumstances, and maybe you want to do something what's called throw an exception, right? You're not doing just a try and catch. You may say if age is greater than 15, or well, age is greater than 102. Let's say that's your max age. Our age is less than 0. If age can't be less than 0, so if age is less than 0, you want to throw an exception. Okay, that's a specific type scenario for that.
Ashton has some questions in the chat.
Oh, okay. Sorry about that. Let me look at that. So yeah, so there's some circumstances that you may be doing some validation on some fields. And then based on that, you want to throw an exception. You actually want to throw the exception. So let's take a look at an example here. So here's a situation where you're basically saying if the monthly investment is less than or equal to 0, throw this new exception. You want to throw a new exception here, right? So, but you do realize, so when you throw this new exception somewhere in your code, you're going to want to catch that exception. If you don't, if you throw an exception, you always want to make sure in your code you're actually catching that exception so you can handle that gracefully. And exception handling is really all about, handling, problems in your code gracefully so that the user, from our perspective, we're programmers, and so we're, it's not a big deal, but a user who doesn't know what any, all this coding stuff means, it either works or it doesn't work, right? And so when when there's a problem in your code that you want it to be gracefully, you want to show them a message. Oh, you did this wrong, or this data was wrong, right? Sometimes, but sometimes there are circumstances where something happens out of the ordinary for whatever reason, and you want to handle those those cases as well, where you may actually even have to close the application because there's some serious problems. Okay, but in most cases we're talking about in a lot of cases here we're just talking about situations where the data's in the wrong format, the user entered a letter instead of numbers, right? Things like that. And so, like I said, you can throw your own exception, but then you want to make sure you also catch the exception. So in this case, let's say the code that throws an exception for testing purposes. Okay, convert to decimal. I'm trying to look to see what this does here. Okay, well, I don't really like this example too much, so calculate, it's not really calling. So, basically, you do whenever, you go ahead and throw an exception, you want to make sure your code at some point, something who's calling calculate future value, you want to make sure that when you call that, you want to make sure that you go ahead and catch that exception, right? Code to rethrows an exception. Yeah, you can also do that. And we'll talk about this. I don't want to get too much into this right now. But basically, you can catch an exception and then throw the exception up higher. So sometimes, especially when let's just say you've got a situation, you got one method calls another method, calls another method. You've got multiple methods. You got a hierarchy of methods. Well, something at the very lowest point, like, maybe the fourth method, in this list, may want to throw that exception back up to a higher place within that hierarchy. And then at the higher place, you want to print out then that's where you want to actually handle that exception. You may not always want to handle that exception at that specific point. And we'll go into that in more detail. I don't want to cause too much confusion on that. So when to throw an exception. When a method encounters a situation where it isn't able to complete the task, you may want to generate an exception to test an exception handler. Okay. When you want to catch the exception, perform some processing and then throw the exception again. Yeah. Okay. And we'll look at examples of that in the future. You can use the throw statement or a throw expression to throw a new or existing exception. When you create a new exception, you can specify a string that's assigned to the message property. Let's not worry about too much of that right away here. All right. Let's take a quick look at a few things here. Second part of this chapter is about validating data. I think, it comes into play with also the exception handling part as well, because based on that data validation, you may want to throw an exception, right? So when a user enters data, the data usually needs to be checked to make sure that it's valid. This is known as data validation. When an entry is invalid, the application needs to display an error message and give the user another chance to enter valid data. This needs to be repeated until all entries on the form are valid. Okay, you may want to perform several types of data validation. Okay, first, the application requires that the user enters a valid data. Okay, we'll just take a look at the example here. Checks that entry has been made. You're just checking to make sure that basically exists. So did the text in the text box, did they enter any data at all? If they didn't, then you're doing a message box show. Monthly investment is a required field. Okay. And this is checks entry for valid data, valid decimal data. Yeah, so here you're doing a try parse. And then if that try parse, if it doesn't successfully parse the data, right? Monthly investment must be a valid decimal value, enter, okay? And it's showing an entry error, okay? And then here's an important thing. This will put focus back into the field that you're referring to here. Okay, dot focus to put focus back into that field. Here's code that checks an entry for a valid range. So in this case, you're saying if monthly investment is less than or equal to 0, then you're just sending back the message. And then in this case, if it's greater than that, you're greater than 1,000, then you're going ahead and sending back a message on that as well. When a user enters data, the data usually needs to be checked to make sure that it is valid. This is known as data validation. When an entry is invalid, the program needs to display an error message and give the user another chance to enter valid data. 3 common types of validation checking are to make sure a required entry has been made, to make sure that the entry has a valid numeric format, and to make sure the entry is within a valid range, known as range checking. To test whether a value has been entered in a box, you can check whether the text property of the box is equal or an empty string. To test whether a text box contains valid numeric data, you can code an if statement with the condition that it tests if the tried parse method and converts the data is successful. And also to test whether the value is within a range, you could use if-else statements. Since it's common to check entries for valid data, it is often makes sense to create generic methods. Okay. So instead of having, especially like you got your on-click events and you've got, on-click, there's others ones that are also available like on-blur events and things like that as well that we'll see a lot more coming up in the next chapter, chapter 10. But as far as like an on-click event, you don't, if you have a complex form, you really don't want to have a bunch of if statements all over the place. So it's, usually it's kind of better to, not have these, 200 line methods. And so it's best to, especially validations, best to have your basic validation methods. And it's also a good idea, because a lot of, you're working on a project. A lot of projects are actually going to have validation type classes or interfaces or classes that are actually have a bunch of different methods that you can use for validation. So, you've got a complex project. You're not going to necessarily some basic type validations that are used multiple places. Whenever you're using something multiple places, you kind of want to create, you want to create a method for that, right? You want to create a specific method so it can be used by different programmers, on the project, right? So we're going to look at a few specific methods here. So here's a method that checks for a required field. So it's basically you're going to be passing in the value and the name of the field, and then you're checking to see if the value is empty, and then in this case you're creating a message, right? You're creating a message here, and you're returning that message. So that's checks for a required field is present, and obviously there are there's other options here that are available within the .NET framework as far as different methods that they provide themselves. But you can also do the same for you can extend that to do your own specific type things as well. Okay, so here's a method that checks for a valid numeric format. So you're using the try parse. You're going to try to parse it. If it can't parse it, you know that it's not valid format, and you're returning the message here is decimal. And here's another one where is within range, right? So the good thing here, well, here you're doing decimal, so this would be specific only for decimals, right? But this will work for any any decimal that you have. So you can use methods like this, where is within range, and so you can be checking things for different places, and you can just use this generic method, right? As long as you pass in the value, the name, and your min max for decimal, right? Since it's common to need to check text boxes for valid data, it often makes sense to create generic methods like these for data validation. These methods can be used to validate entries on Windows and non-window forms, since they don't require the window form namespace. Then you can code them in a separate class, okay, and then you can store the class in a class library. So yeah, this kind of just says that it's probably a really good idea, and most projects you're going to have some validations that are available to use in a project, right? How to validate multiple entries. Okay. So let's just take a look at that here. So here you've got three different ones. You're returning three different error messages, right? Let's take a look here. get to if. It's basically if it's empty, show messages, error messages. Okay. Is valid data. It's just showing this is a method where you're looping through everything pretty much. Well, I won't say looping through, but you're validating multiple different things in the same one here, right? You can use the validation methods as shown previous to validate multiple entries. Then if the entries are invalid, you can display a dialog box that describes the errors. All right, let's see what else we have in here. So let's just go ahead and review the main concepts here. So an exception is an event that disrupts the normal flow of programs instructions. C# provides a robust mechanism to handle exceptions called structured exception handling. So in this case, you've got a try. You have a try basically on, you're trying to access the, right here, you're trying to access the fifth one, all right? Now, obviously, this is automatically going to throw an exception, but in the real world, maybe this 5 here is something that gets passed in from somewhere else, right? Maybe this is getting passed in from somewhere else, and you don't know this is going to be an exception, right, at that point in time. So let's say the number 5 gets passed into this field. Well, all of a sudden, numbers, you only have 3 here. This is at index 0, index 1, and index 2. You're trying to pass in, pass in one at index 5. That doesn't exist, right? So this is going to throw an index out of range exception. So here's your try and here's your catch, and it's just going to go ahead and print this message. How exceptions work in C#, exceptions are objects of the system exception class or its derived classes. So not, even though at the root every exception is going to inherit from system exception, there are other exceptions underneath the system exception, and you may just be inheriting from that one, right? Not necessarily for exception when you create your own. We'll take a look at that here in a minute. So when an exception occurs, a program jumps to the nearest catch block to handle it. Yeah, because sometimes, you want to be careful doing a lot of nested try catches. Just kind of causes confusion, right? Because you can do some nested things as well for try catches, but try to keep it simple as possible. So the try block contains the code that may cause the exception. The catch block contains the code that runs if an exception is thrown. WinForms provides dialog boxes for interacting with users. And this is just showing you, you can use a dialog box to show your errors. Structured exception handling. Structured exception handling uses try, catch, and finally blocks to manage exceptions in a structured way. So here's your try, your catch, and then just remember you've also got your finally. And obviously you have multiple catches, right? Multiple catch boxes. So you're going to want your most specific exceptions first. Then the last one in your list would be your general ones, right? Depends on if you are using multiple exceptions or not, right? If you know some block of code is only going to throw a specific exception, you don't necessarily have to have that general exception there, right? You can have just your specific exception. How to catch an exception. So here's a case where you're just doing a try.catch. Remember, if you want to use the specific specific methods that's available to exceptions, which is message. A message is one of them, and get type is another. make sure, you're going to want to go ahead and put a variable here. This is a user created variable, what you call it. You don't want to use an E because that's kind of already used. You want to use an EX. EX is a nice, good one to use. You can call it other things as well. I've seen people do, things like exception FE, like that here, or different things, that are make it more specific. Okay. But yeah, if you want to use that message or the get type, make sure that you have to prefix that, right? So in this case, you're prefixing that with EX. Okay. How to use the properties and methods of an exception, just like we're showing here. You're catching an exception and you're doing the message, and then and in this case, you're doing a stack trace, right? So, and then remember, stack trace is always going to be the most recent part of the exception. The most recent message is going to be the top one in the list, right? The most recent ones, and the one that happened at the beginning would be at the bottom of the stack, right? Or the last one in that. Okay. How to code specific types of exceptions. So in this case, you've got a index out of range exception. Here you've got a generic exception. You just want to make sure that you include your most specific one first, and then after that, your general exception. Most specific to least specific. How to throw an exception. So this is another option you can do. Sometimes, it just depends on your needs. And I don't want to say one's necessarily better than the other. Maybe just depends on the situation where, you may be doing some kind of validation and you just want to go ahead and return a message back to the WinForms app. But, there's other cases you may want to actually just throw an exception. So here's in a case where you're checking to see if age is less. Here, age is less than 0, so you want to throw a new argument out of range exception, right? And so you can do that. You just have to realize that if you're not catching this exception somewhere else within your code, that's actually calling the method that this block is in, then you're going to need to be doing that. You got to handle it somewhere, right? Let's see here, future value application. Yeah, this is just showing the example here on that. How to validate data. So data validation ensures that input data is correct and meaningful. So a good rule of thumb is never, I was always told never to trust, the user data. Never, you never know what's going to be entered into the data. Never assume that they're going to enter the correct data. So you always need to validate your data. All user data should be validated before you use it. Because the sooner you figure that out, the best. You want to. So right when somebody hits a click button, or however the code gets executed after some user enters data, the first thing you want to do is really validate the data before you do anything else. Just another word of wisdom, so to speak. This applies more maybe from a web applications, but you want to. You never know where something could be, some virus or something that's some bot, something that's actually trying to manipulate things for nefarious reasons. And so you always want to make sure, that's why you always want to validate your data to make sure that something's not being entered that's not supposed to be entered. There's other reasons for trying just users. It's also from a security standpoint. You also want to make sure you validate your data as well. Okay, so here you can validate a single entry using a simple conditional. Here you're just testing is null or white spaces. So if it is empty, then you're showing a message back to the user that name is required. And when I was speaking earlier, I was saying that there was some .NET type, so here's some string utility methods that .NET has, right? So you can use this, but you may also want to create your own specific methods for some specific things you're trying to do. And we've seen examples where, we were doing is decimal or that, but that probably isn't a good way because, there's already those types of things that are available to use within the .NET framework that you can use by default. There's a lot of these utilities, like in this case, you've got is null or white space, which is utility of the string class, right? So, but there may be some other specific validations that you're wanting to do that you're going to create your own methods for that, right? How to code generic methods for data validation. Generic methods make validation reusable across different inputs. So in this case, you're doing an is valid decimal, right? And you're returning if it's true or false, right? A Boolean. Is this true or is this false? It's creating your own generic validation method that you can use in multiple places. Depends on what your needs are, right? Here, how to validate multiple entries. So here you're doing, you're validating a form. Looks like you've got this validation form, and you've got a monthly investment and interest rate in years. So if you got if statement here, so here's your message. If it isn't, if you have a validation error, otherwise you're just going to return false. And here's, so you got 3 different ones here. Okay. Key definitions. Okay, so exception is an error that occurs during the execution of a program. That may occur. Shouldn't say as an error that occurs. It may occur. Exception may occur during the execution of a program. Throw an exception is a process of signaling the occurrence of an exception. Catch the exception, the process of handling an exception that was thrown. So just remember the catch is handling the exception. The exception handler is the catch block, right? Not the try block. Exception handling, the mechanism to handle runtime errors. So remember, exceptions are always about runtime errors as opposed to compile time errors, right? Compile time errors don't use exceptions, right? It's just that happens based on compiling of your program. In the case of the stuff we're doing, it's kind of automatically compiled, right? But, exceptions are all about runtime exceptions, okay? So structured exception handling using a try, catch, and finally blocks. Try catch statement, the statement that attempts to execute code and catches the exception. The exception handler is the code that processes an exception. Let's go down to stack trace. Stack trace is a list of all method calls that were in progress when an exception occurs. And then you go through that in reverse order. Finally block. So the finally block is code that executes regardless of whether exception occurs or not. So, it's important to remember your finally block is always going to get executed. If you have a try block, right? You have to have a try block, though, to have a finally block. You can't just have a finally block without a try block. You can have a try block and your catch blocks, and then you have a finally block. So even if your exception does not get thrown, that finally block is going to still be executed, and the code within that block will be executed, I should say. And finally blocks are good for cleaning up resources such as database connections, or maybe like input-output streams, writing and reading data from a file system. Them are good examples of things that would be cleaned up in a finally block. A throw statement is a statement used to signal the occurrence of an exception. Data validation is a process of ensuring input data is valid. Then you have the idea of range checking, ensures that the input data falls within a specific range. All right, so that's that. Let's go ahead and look through a quick little example here. So here I've got an age exception example. And so what I did was I created, because you're going to be doing things like this for the labs, you're going to have to create your own exceptions. So in this case, I created this age exception, right? And this age exception inherits from exception, right? You're going to be doing that, right? You're going to have to make sure that you include that. So here, let's do this real quick. I do want to go over concept. So here's different exceptions. This is the Microsoft documentation. So here's your exception. So this is obviously the root exception of everything, right? This is the base class for all exceptions. And here's different ones that can be thrown. These are all exceptions provided by the .NET framework. Okay. Now in this example for the age exception, I'm inheriting exception, but that doesn't mean that you can't inherit these other ones, right? You can inherit index out of range exception, right? Obviously, when you inherit index out of range exception, right? There's also a parent of that, which is exception. So by you inheriting index out of range exception, you're also the base class of that is exception, right? So the base class is always exception, right? But I just want to let you know you don't always necessarily have to inherit exception. You can inherit other ones as well, okay? So here's like an argument exception. So if you have an invalid argument, if you want to write some code and you want to create a custom argument exception, then you would inherit argument exception as opposed to exception, right? All right. And, this is always good documentation to check out. Sometimes I know it can be a little complex and confusing, but, it can be very helpful to look through this documentation, become familiar with using the documentation, right? So here, like I said, it created an age exception, which is inherits from exception. And this is just saying invalid age was provided. And I'll basically just have console.writes if this takes place, right? And you want to make sure that when you inherit from exception, you also inherit the base, right? And so if you look at this, because by default, exception has a message, right? Exception already has that message available. And then in this case, we're creating our own specific invalid age provided. Okay. And this is just overloading those constructors, all right, that are available. And this is overloading the base ones, okay. So then if we go back to our program here. So first was just to create our age exception, right? Now that we've got our age exception created, and here we're doing a range check, right? And so if age is less than 0 or age is greater than 120, then what we're doing is we're throwing a new exception, okay? And then if it's not, it's just going to print the correct age, right? So either one or the other. And here we're just in this main method. We're calling. We're doing a try, right? And then we're calling, here we're just getting from the read line from the console, we're getting the age, right? So this age here doesn't, even if something was wrong here and this threw an exception, this is not going to call age exception, right? If something goes wrong here, something went wrong here, it's going to call exception. What's going to call exception is this one. And if we look at this and we go to definition, okay? So this throws that exception right there, right? So here we're calling the method that may throw an exception. If it does, we're catching that exception and we're printing out the message of that exception. So this is catching the custom exception, right? And that's about it here. But I just wanted to point that out because I know in your labs you're going to have to create your own custom exceptions, and basically that's how you do it. Just like any other class, it's just a public class. This is the name of your class, and in this case, the base class is going to be exception, right? The derived one is your age exception. And make sure that you also do this as well. Okay, your dot base. All right. So let's just run this, I guess, real quick. This ain't really going to show much here. So if we do an age outside of that, let's do 120. This is just showing you that. Okay, I guess we could do a stack trace here on this, couldn't we? Let's go here and we're doing a try and we're doing a catch. Why don't we go ahead and do that as well? Why don't we do so let's do the stack trace here. And let's try that again. So in this case, we want to look at that stack. Let's see if this works. Hopefully it'll work. So here it's basically showing you, here's the stack trace. So it's telling you where this error happened. And it's showing you all the way from the beginning, right? So this is the last thing that it did was validate age. Then it's showing you what was executed before that, right? You executed the main method, right? So it's obviously this is a short little one here. Obviously in a program where you got something much more sophisticated, you're gonna have a much larger, much longer stack trace, right? Just wanted to show you that. So that's all I have here for today. Please let me know if you have any questions.